Good evening, students. I'm going to make one request of you. Is when you come onto the online class, I'm going to ask you nicely if you can just say, good evening, sir, to get my attention. Because I log into the class, I don't necessarily look at the chat, and you guys are coming to the class and just sit down. I know, no greeting, I am also here to help you when you get into the place of work. You can't enter a room and you see somebody and you just go and hold a seat and you are present. No, you have to say hello, good evening. If you want, you can say, how are you? But I have been watching and I really think that it's now time for me to say something. You cannot or shouldn't come to my online class and I am sitting and looking at the time and say, but wait, what is happening? And I'm seeing one, two, three students in the class. Well, Mary, I know you sent hello and I responded to you. But no, it's not nice. And as we prepare, to be fully qualified to get into the place of work, we need to be able to understand that basic etiquette. When you go into the place of work and you're invited to an online meeting, the basic etiquette is good afternoon, good evening, you unmute, or you mute. You unmute and then you speak and then you mute. But it can't just slide in and then it's in poor taste, it's not good manners. So I'm hoping that come next class, I'll see an improvement. All right, thanks. So good afternoon, good evening rather. I'm going to wait a few more minutes, maybe about 4 more minutes, um, for those who are in transit to log on and then we may begin. I have some information for you that we need to share at the top of the class. Thank you. All right, so it's now 6:25. We're 25 minutes into our session. Let us begin. So I got word from CCCJ, well, not from CCCJ, from our SU, Assessment Services Unit or Exam Center. On the course delivery plan, I have up until March 1 to complete the syllabus. As I said to you, this piece of the Unit 7 is I'll use these as I go along. So I don't need to really spend much time on this. But the exponential and logarithmic function, I'll have to do the differentiation of explicit and implicit exponential and logarithmic functions from up top. Up top meaning right here, differentiate implicit algebraic functions. Let me spotlight so you can see what I'm talking about. Differentiate implicit algebraic functions. This one here say differentiate explicit and implicit exponential and logarithmic functions, right? And this one up here was implicit algebraic functions. So when I reach here, I may just include the other types of functions indicated so that at least we can cover those. Because CCCJ says that I was proposing that our exam would be on March 4, CCCJ is saying that the exams cannot be extended to that week and the exams will have to be completed by March 1. So I volunteered that because I would not finish the syllabus earlier, as they had it on the 26th, that we do our exam on the 1st. So I can say to you, unless otherwise told, so far, the conversation and the email that I got is saying that we have communicated to the CCCJ that our exam is going to be on the 1st of March. So you can start making your plans and your preparations. I know we saw Calculus 2 on it. I also spoke to them about that. They are going to amend in the second draft of the timetable to send to us. Let us hope that come the second draft, we see March 4. So for those of you, March 1. So those of you who need to give ample notice to your places of work, you can let them know it is looking like March 1 and preparations can be made. I cannot speak to the time of day for the exam, as that information comes directly from CCCJ and not from the college. So I can only provide you with a March 1st date, nothing more as it relates to time. What it means now, I have to be purpose driven so that I can cover the syllabus before then to leave time enough for us to do our preparations. So the questions that Astinil was asking last class, if we could do a revision on the Sunday, the 3rd, all of that is now through the window and that we have to make alternative arrangements. So I say this to say to you, students, your exam is going to be March 1. I will collect the papers the end of the exam on the 1st of March. I will be locking off. When I say locking off, I won't be taking any telephone calls for the weekend. I'll be locking off so that I can complete marking those papers and submit those papers by Monday morning so that when we would have our class the afternoon, those persons will know whether or not they were successful in Calculus 1 to make the necessary adjustments. So your EducaSoft pieces that remain outstanding, I'm going to ask that you complete those because when I'm extracting those grades, I don't want nobody to say to me, sir, can you give me 2 days because I want to, I'll complete it at that time. The answer, they are resounding no, because I'm not going to be late with my grades so that I look bad because you did not follow my instructions by starting by completing your assignments online in a timely manner. So I'm saying this again. I've seen some people moving, but some people are yet to log on to EducaSoft to get going. Some people started off out the back and still have not done anything more on the platform. So I'm saying this for the person who just came on. I'm saying this. Your exam looks like it's going to be on the 1st of March, 2024. You must complete your Microsoft pieces because the end of day on the 24th, on the 1st of March, I will collect your exam papers. I will mark those exam papers. I'll upload those exam grades to the system. I'll release those grades to you on Monday before our 5 o'clock to 7 o'clock session. So those persons who will need to know whether or not they're qualified for Calculus 2 will have the information. But those of you who don't complete the assignments on time, you will be getting a 0. I'm not going to be entertaining any stories because I know I will not be late in submitting my grades. I will not be late in submitting my grades. So I'm saying to you students, please make sure that you complete and complete my assignments on time. Are there any questions? All right, so there are no questions. So
No,
now,
sir.
all right, cool, thanks. So now, tonight again is going to be a special night. I'm on to unit 4. So all that I have here, something have to give. I have to move a little faster because I had it to finish on the 1st of March. We don't have the 1st of March to wait on. So tonight is unit 3, we're on to differentiation. I have to jump into differentiation, and I'm hoping that I can finish differentiation by 8 o'clock, finish off all of this by 8 o'clock. If not, yeah, by 8 o'clock, thereabout. And then I'm hoping that I can start a little bit of integration tonight. I'm really hoping. If I don't do this, guys, I'm going to be in serious problem. I know I wanted to start it on the 12th, but I have to push a little bit of integration into the mix. And hopefully I can, integration is not long enough. Hopefully I can get some stuff in it. So with any further ado, let us see how far we can get it at so that I can, because the application is going to take a little time. But anyhow, I'm getting a little flustered, but I don't need to transfer that fluster, um, flustering to you guys. But we will see what can happen. We will have to get there. Let us just work with it. Let us work with it. All right. So you have a copy of of your of this on your Edicosoft, and you can go right ahead and look at it. Good evening, Astina. Go right ahead, look at it, and okay, Simon, I just seen your message. So you can have a further look at what is expected of us. Let me stop share so that I can, I'll just close this one here so that I can then bring up my notes. Oh Lordy. Let me see if I can fix that. Um, hold on. Suit. Oh Lordy, Lordy. With 1, 2, 3, 4, 5, 6, 7. I'm just trying to organize my notes in. Then it says new folder. So new folder is supposed to be. Online notes. All right. We're on to differentiation. Guys, please, I'm gonna ask that you work with me. We are going to get this thing done up. We are going to overcome. This is not going to kill us. So the last thing we looked at was the quotient rule. And I gave you a question. I know Aston was asking me about going through some of those. I would have responded to her. Let's hope that she's a little bit more comfortable.
What have you responded to her with, sir?
You were having a difficulty with one of the questions in the quotient rule. And I'm trying to find the question. And I responded to you in class. And I was saying that I'm hoping that you would have understood and it would have brought some clarification.
Yes, or it's a case where you were supposed to go through the question and you did the recall that you say you weren't supposed to do, so you're supposed to finish that question this class.
No man, that's not it. It was something before.
Okay.
But yeah, it was something before. But I remember that though, and I'm actually looking for it and I can't find it. Remember what the question was asking you?
Yes, it was
Read
y
the question.
equal
Uh-huh.
x minus 3 all squared over x squared minus 7.
All right, let me look for that.
Sure, you asked about the 26 for exam?
Yeah, man, I did. Oh, you joined late. I did. We are pushing it down to the 1st of March because I told them that the 26th just couldn't work. So pushing it down for the 1st of March. So they got word from CCCJ. Let's hope that the second draft of the timetable will indicate that change. And Calculus 2 is going to be removed from the timetable. So the 26th is not going to be there, none at all, because of the election day, right?
Yes, sir.
I still can't find a question there. Say the question again, please. Oh, lordy.
Y equal brackets x minus 3 all squared divided by x squared minus 7. It's the paper that has the quotient rule, the product rule, and the chain rule. Yeah, product, chain, and quotient. It's also the paper with the x squared minus 3 all over x minus 7.
X squared minus 7.
X squared minus 7 is the one that we're supposed to be working. And I'm saying it's also the paper that has x squared minus 3 over x minus 7 as well.
All right, so for the last time, can you tell me read the question for me? I think I found it. I just want to make sure it's the right question. Can you read it for me again?
The question that we're supposed to be finding?
Yeah.
Y equal x minus 3 all squared over x squared minus 7.
Got you. Thank you.
Yeah.
Share screen. Just look to see if that's it. That's the one.
Yes, sir.
All right, good job. All right. Oh, oh, come on, don't do this to me now, please.
Sir, why you move it?
Hmm?
Why you move it?
Mm-mm.
I was writing it.
Mm-hmm. I'm coming. That's the one?
Yes, sir.
Okay, good. So I'm able to write more. And I wasn't moving anything, I was trying to find my pencil. All right. So that's one option. in doing the question. Let me give you another option. Y is equal to x minus 3 all squared all over x squared minus 7. All right, work with me. And you see that it's pretty much the same thing, but dy by dx is equal to the denominator times the differentiation of the numerator. When I differentiate the numerator, it's going to be a power, so we're going to make 2 times x minus 3 to the first times the differential of the inside, which is 1, minus the numerator, x minus 3 all squared, times the differentiation of the denominator, which is times 2x, all over the denominator square, which is x squared minus 7, and that is now all squared. dy by dx is, let me just fix that up, it's going to be equals to 2 times 1 is 2 times x minus 3 times x squared minus 7 minus 2x into x minus 3 all squared. And that's all over x squared minus 7 all squared. Half a second. All right, sorry about that. So now, when I look at the numerator, remember we said that we're not touching anything in the denominator? When I look at the numerator, I recognize that my x minus 3 is common. And as a result of that, I'm going to factor. As a result of that, I'm going to factor. On this side, on the left-hand side, what I did was to expand this x squared into x to give me x cubed. But what I was saying to you last class is that once you see something common, as in those cases, the next thing to do is to factorize. So I'm going to have dy by dx is going to be, and I'm looking to see what is common. Now, if I look, you also recognize that this 2 is common to both sides, stark truth. Let me hear you.
True, sir.
Yeah, man. So I can't take out the 2. It's common, so I can't take it out. And I can also take out a x minus 3, right? And when I take that out, take out the 2, I take out the x minus 3, I'm going to be left with x squared minus 7 on that side. X squared minus 7. I can put that into parentheses if I want. And then minus, I took out a 2 from here already, so I'm just going to be left with an x. And then I took out an x minus 3 on this side. But I took out an x minus 3 from this side, but I have an x minus 3 all squared. So what I'm going to be left with is just a x minus 3, one of them. Look at that and tell me if you agree with me. I would have
agree.
very nice. I would have removed one of them, because when I factorize, I'm actually taking the smaller thing out. So I would say, for example, 2 is a factor of 4, but 4 is a multiple of 2. 6 is a factor of 12, but 12 is a multiple of 6. So when I speak about factor is a smaller number, but multiple is a bigger number. So when I'm factorizing, I can't take out the x minus 3 all squared, because the x minus 3 all squares I have to take out the smaller of the two. So when I factorize, I'm going to be left with just this x minus 3 on this side, because there are 2 of them. And when I multiply this x minus 3 by this x minus 3, I'll get my x minus 3 all square. And when I multiply this 2 by this x, I'll get that my 2x. So what I'm going to do now is to simplify on the inside of that parentheses. Just to simplify it, and that will take us into our answer. So dy by dx is going to be equal to 2 times x minus 3, and I'm going to simplify that. This is just going to be x squared minus 7, and then negative x times x is a negative x squared, and a negative x times a negative 3 is going to be a positive 3. X squared minus 7 all squared. So my dy by dx is going to be equals to 2 times x minus 3 into, you'll recognize that this x squared cancels with that x squared, don't it?
Yes, sir.
All right, but I also left off an x right here, so do you see that? Negative x times x is negative x squared, negative x times 3 is a positive 3x. Agree?
Yes, sir.
Right, so I'm going to have 3x minus 7, and that is going to give me over x squared minus 7 all squared. Now, you're going to look at the question. You're going to look at the question and say, but sir, all I'm seeing is this and this. But this here does not resemble anything that we have over this side. Not a problem. I can prove that it's the same thing. I can prove it. And I'm going to just prove it right here to say 2 into x minus 3 times 3x minus 7. I'm leaving my 2 on the outside here. Then I'll say x times 3x is 3x squared. X times negative 7 is a negative 7x. Negative 3 times a positive 3x is going to be a negative 9x. And negative 3 times and negative 7 is a positive 21. And then 2 times 3x squared is going to give me 6x squared. And 2 times negative 7x, whoopsie daisy, I don't need to do that yet. I'm going to say that is equal to 2 times 3x. I'm grouping those. Negative 7 minus 9 is a negative 16x. And plus 21. And when I distribute the 2 over there, and I'm going to get 2 times negative 3x is a negative 6x squared. Sorry, positive 6x squared. And 2 times negative 16 is going to be a negative 32x. And 2 times 21 is going to be positive 42. So now you see that what it is that I have here is the same thing that I would have right here. All right. So the right-hand side looks a lot cleaner than what I had done on the left. But if you presented the one on the left and the question didn't ask you to simplify, I would give you full marks for it. And oftentimes, when I give you a differentiation question, they may not even ask you to simplify. Sometimes they do. But whichever of the 2 methods you would have given, I would have given you the full marks. So on Wednesday, when I was doing the question, I was like, oops, what did I do there? Because I wasn't looking to see this is the same thing as that. Not that the question is wrong, you know. I just prove to you that what I have on screen is the same thing. I think, however, what I may wanted to have done is to show you this expansion right here. But whichever method, plausible, get the same answer, good to go. How are you feeling?
A little dazed, but okay.
Okay. And tell me why you're dazed.
Trying to soak in the factorized aspect in comparison to the one on the left.
Which one you're more comfortable with?
I'm not sure, but I'm leaning towards the left.
All right. I'm going to tell you why.
I know I sometimes have an issue with factorizing.
I'm going to tell you why. It doesn't always happen because I was in a class on campus yesterday and the questions that were given did not include anything for them to factorize. Put it this way. I am teaching you so that you're not only able to cook chicken. If you want a little beef, you can cook the beef. If you want a little fish, you can cook the fish. If you want a little oxtail, you can cook the oxtail. So I'm teaching the fundamentals of cooking so that you can go ahead and explore and to explore different meat kinds. So I'm not going to just show you one way of skinning a cat. I'm going to show you multiple ways. And then now you can add your own flavor. And then you can say, hey, sir, boom, I'll come up with a third way of skinning the cat. And I was like, plausible, full marks. All right. So that's what you need to do. Am I to understand that you are understanding this now? I just heard from Astonil. What about the rest of you?
Sir, it's the same for me, sir. The simplifying seems more a little bit easier.
Okay. All right. I guess with practice we will get there. Anybody else?
Yes, sir, I understand what you just did, and I understand the one on the left as well.
Okay, good job. Good job. And that's it. I want you to be able to understand both methods. One method, I won't say one method is preferred over the other method. Sometimes you're doing the question and there's nothing that is common, and you have to use the left-hand side method. You have to use the left-hand side method. And there are other cases where you have something that is common, and you don't have to use the left-hand side method. But if you use the left-hand side method, you won't get it wrong. But you can go ahead now and use the right-hand side method and just factor out the stuff and just do your stuff and just show off that you know how to factorize and can pick up a full marks to the question. That's what it is. All right. Am I allowed to move?
Yes, you're allowed to move.
All right.
Mm,
Let
I'm not
me
sure
go ahead.
if you saw I sent you a message today or last night or sometime thereabout.
Hold up, because I didn't. Let me just check.
And sir, Edikosafa confused my brain.
Okay.
Let me tell you when I sent the message last night.
That's not. Send me one just now, please, and I can because send me one just now, please, my dear. Okay. Okay, easy fix.
Okay. Thank you.
Mhm. All right. Let me. Hmm. Can you see example 4?
Yes, sir.
I don't know why I decided to just change something there and use it as a power.
You know, but I would done.
I want you to put our HR calling me. I need to answer this. Start working on question 4 for me, please. I'm coming back to you in half a second. Finish, guys? How we stay?
Good, sir.
Finish?
Yes, sir.
Good job. All right. What about you, Mario, Simon, Tristan?
No, sir. But you can go ahead.
Yes, sir. Finish.
Mhm. How we stay?
My answer did incomplete because I never cancel the x minus 7 at top with the denominator.
Okay. All right. Very good attempt, though. Nice. Um, also like the honesty. Simon, Tristan, Mario. Oh, Mario said no. What? Simon, Tristan? You're allowed to answer me and say I don't get it, you know. Don't let me ask, call upon you and not responding to me. So you're allowed to come and say, no, sir, I didn't get it, and we can move on. Hmm. All right. So we're moving. I want you to make an attempt for me of question number 5. Quick and fast. I give you 1 minute. Quick and fast. Question 5. G of x, and I want you to use the quotient rule. What we stay?
Try the answer.
Finish, sir.
Very good. Let me see. What's go for your answer, Simon?
4x squared minus 13 all over x minus 1 squared.
Ah, you left off the x, so you added the x plus to the 5 to get 13. Look at that.
Yes, sir, I saw it.
Mhm. Good attempt, though. Very good attempt. And I guess the more we do it, the better we get at it. So I won't use a whole class to go through those stuff because, as I did say to you, there are other things we need to look at. All right, so I'm waiting on Mario. At least give an attempt, please, sir. Please. This is a new question. Give an attempt. Waiting for Shamar to finish off this and let me know if he has got that answer. Then we move along. Shamari, waiting on you here.
All right, sir. Finish now, sir.
What is you agree with it?
Yes, sir, I agree with it. But look at the third step or the second step, where you have the 8x into the x minus 1. couldn't the x minus 1 have been couldn't you have cancelled one of the x minus 1 from the numerator?
Which one? This one here?
Can't see where you're pointing, sir.
Yeah, that's what I'm wondering why it's not. Let me go again. I wonder why it's not. You're wondering why this piece here could not be cancelled into this one on here?
Yes, sir.
No. So you cannot cancel beside a negative sign. See the negative sign here? You can only cancel beside a multiplication sign. So that's why we have to factor. Follow me?
Yes, sir.
Right. So just remember that we can't cancel beside a negative sign or a positive sign. It can only be a multiplication sign that we can do that cancellation. So I have to bring everything here under one term and then do that cancellation. All right. I'm happy that we are there. So try number 7 for me, please. I'm just going to do about 2 or 3 more of these questions, and then we'll move into some other things. I want to move into some implicit differentiation. So try number 7 for me, please, quick and fast. And let me see where we are. Number 7. Yeah. How is Steve? How is Steve? Talk to me.
Finishing up that one, sir.
Okay, cool.
Finish now, sir.
Okay. Anybody else? Ashley, Simon? Simon?
Sir, you can move on. I was distracted, so I couldn't really finish it much.
Okay. So number 7. That's what I got for my answer. Always stay with it. Well, it will be you, Shamari. Always stay with that.
Good, sir. That's what I got.
Good job. All right. I have more questions to give you on the product rule. So we just did some questions with the product rule quotient rule, product rule quotient rule. I have many more questions to give you with that. But I also now need to spend some time looking at some differentiation of exponential functions and the logarithmic function. The exponential and the logarithmic function. Spend some time on that. And then what I want to do, I can do 1 or 2 questions on those. And then what I want to do is to look at the square root function as well. And then hopefully I can get into let me see if it's here. I can get into, it's not on this one. I can get into, I have more past papers that I would have done. Guys, we need to get past papers and start working. Oh, I think the rest of this is just past papers. No, this is where I want to get into. I want to get into the implicit differentiation tonight. I want to even at least start it, the implicit differentiation. That's what I was looking for. All right. So let us go with our exponential function. Here, the differential of the exponential function e to the x is e to the x. The differential of the exponential function e to the x is e to the x. When I differentiate the exponential function e to the x, I get e to the x. Why, sir? Because of this. Because of that 1x there. Because when I'm differentiating the exponential function, I'm differentiating the function. I'm going to get e to the x, but I also have to differentiate the power. I'm differentiating the power. I'm differentiating the power. Hold on 1 minute, please. All right. And the differential of x is just going to give me 1. So that's why I have this here as 1 e to the 1x, which is the same thing as e to the x. On the other hand, let us look at y equals e to the 2x. Do you recognize that e to the 2x still appears in the answer as e to the 2x?
Sorry, can you repeat that?
Now I'm saying, we agree that e to the 2x still appears in the answer here as e to the 2x?
Yes, sir.
Watch this trick. E to the x squared, you still have the e to the x squared. E to the 3x squared plus 5x minus 7, e to the 3x squared plus 5x minus 7, e to the 3x, e to the 3x, e to the 3x squared over that, e to the 3x squared over that. What's the point I'm making? The differential of the exponential function is the exponential function itself. It always ends up in the answer. The same function given is going to be the same function that ends up into the same answer. However, there's another piece that must be there. You notice this. You notice this x squared here. I'm going to differentiate the x squared. When I differentiate x squared, what do I get?
Two x.
Good job. And that's a 2x right here. And that's my final answer, 2x e to the 2x. Again, when I differentiate 2x, what I get?
2.
2. And that's why I get this here as my answer. When I differentiate 3x squared plus 5x minus 7, what do I get?
6x plus 5.
And that's how I get the 6x plus 5. And so you get the gist of it. When I differentiate 3x, I'm going to get 3. When I differentiate 3x squared over x plus 1, this is what I'm going to get. So the point I'm making is for the exponential function, the differential of the exponential function is the exponential function itself. Is the exponential function itself. But what I'm going to be doing is to differentiate the power and multiply by that. Tell me that you get what I'm saying.
I think I get what you're saying, sir.
All right. What about the rest of you though?
Yes, sir, I'm following along.
You just differentiate the power, you multiply by that, and then you just put back the original.
Yes, sir. Right there, so. Maria, I'm sorry, Aston Hill. Aston Hill.
Sure, you calling me?
Yes, ma'am.
What were you saying? Sorry.
Are you with me? Are you understanding what is happening here?
I understand what's happening. However, my computer starts malfunctioning.
But it's a good thing
I'm
that you're in a
here.
computer course.
Say that again, sir?
It's a good thing that you're in a computer course, so you know how to fix it.
Okay.
I don't like what that sound. Ah. All right. All right. Let me give you a few questions to do on this, and then I'm going to move. So I can tell you, this is not difficult. So I'm not surprised that you guys say that you're understanding. It's not difficult, and the logarithmic function is not difficult either. If you just follow the rules, I point it out to you, you should be good to go. So that part of it is also not difficult. All right, let's go. So I have a notation here. Please note that the differential of the exponential function is the exponential function itself. And then we're going to talk about the logarithmic function now. The logarithmic function, ln x. So whenever I say ln x, it's not in. When I put it on the board, some students will say in. It's not in, it's ln x. So the differential of the logarithmic function, ln x, is equals to 1 over x. The differential of the logarithmic function, ln x, is going to be 1 over x. The differential of the logarithmic function, ln x, is going to be equals to 1 over x. Sir, what it is? Yes, it's 1 over x. But you notice here that this is simply 1x. So I'm differentiating that 1x and I'm going to get 1. Says let me multiplying that by 1. Says it's going to be 1 over x. Let us look at the function y equals ln plus 2. The differential of the logarithmic function, ln x, is 1 over x. All of this 2x is representing x. So it's going to be 1 over 2x. But I'm going to multiply by the differential of the function 2x to give me 2. So what I'm going to have is going to be 2 over 2x. And now the 2's can cancel, Shamari, leaving 1 up there. So I'm going to have 1 over x as my final answer. Similarly, this is my function. but the differential of the logarithmic function is going to be 1 over x. So it's going to be 1 over the function x plus 1, see it right here. And then I'm going to multiply it by the differential of the function here. The differential of x plus 1 is going to be 1. So it's going to be 1 over x plus 1 as my answer. Any questions? The differential of the exponential function is the exponential function itself. But remember now, we're going to be looking at the function. We're going to be looking at the function, and we're going to differentiate the function and multiply it by the exponential function itself. For the logarithmic function is going to be 1 over x. Whatever the function is, you're just going to put it over 1. Put 1 over it, 1 over the function. But you also now need to multiply it by the differential of the function. You now need to multiply by the differential of the function. You now need to multiply by the differential of the function. Any questions?
No question here, sir.
Good job. All right. And so I have some mixed examples here on logarithmic and exponential functions. I have some mixed examples here on logarithmic and exponential functions. What I want you to do for me, is I want to give this one attempt. Y equals x squared, sorry, y equals e to the x squared over x plus 5. Y equals e squared, sorry, y equals e raised to x squared over x plus 5. Try that one for me. I'm only going to be doing a few of these questions here because I need to get to the implicit differentiation tonight. And we have about an hour left. Hi, Adrian. Augustine.
Sir, I'm trying to think. I know if it's right.
All right, and that's the spirit, you know. I've never ever ever asked you to do it and get it right. What I want you to always do for me is to make an attempt. Always want you to make an attempt. Anybody else?
Yes, sir. I made an attempt on it.
All right. Alrighty. Let us see what you got for the answer. Simon.
X x over x and then over x plus 5 squared. I'm not sure, over x2 over x plus 5.
That's so mix up though, Simon. Real talk. That's what I got for my quotient differentiation. You know, so the e to the x squared over x plus 5 is going to come back into the question, don't? Because you know, say, you know that is the differential of the exponential function is the exponential function itself. So what you need to do is to ensure that your quotient differentiation is correct. You need to ensure that your quotient differentiation is correct. All right, so you need to make sure that the quotient differentiation is correct. So let's go to the quotient. Remember, the quotient says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squared. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So what we're doing here is to say the denominator x plus 5, the denominator is x plus 5, so it's going to be the denominator times the differentiation of the numerator the denominator x plus 5 times the differentiation of the numerator, which is going to be 2x. So the 2x right here, minus the numerator, minus x squared, times the differentiation of the denominator. And the denominator is going to be x plus 5, so it's going to be 1. And it's all over the denominator square. And then I don't have anything to factor out, so I have to expand. So 2x times x is 2x squared, right here. And 2x times 5 is going to be 10x minus x squared. And 2x squared minus x squared is simply x squared. And the 10 stands alone, so it's going to be plus 10x. If I want, I can factor it out and call it x times x plus 10. So this is going to be what it is that I'm multiplying. The differential of my power will give me that, along with the original exponential function itself. So really and truly, this is not difficult to know. The differentiating the exponential function ensures that you know how to differentiate. Because the exponential function, the differential of the exponential function is the exponential function itself. So all you need to do is to differentiate the function. and write it by the x and write back the exponential function into the stuff. And you're good to go. Question? All right, so I give you one as a quotient. I'm going to give you one here as a product. Try number 2 for me, please. Try number 2 for me, please. How is it?
Try, I think, sir.
Nice. Anybody else? Talk to me now. Anybody else? Shamari said try something. Anybody else?
Sir, I did something, but it's incomplete. Can you explain this one?
Okay.
Sir, also Asani said to check the chat.
Is it something in the chat? Let me see what seems to be her problem with her computer. Oh, sent in the chat. I was going to WhatsApp. I have to. Okay. Thanks for pointing me to that. All right. My answer is that. Who got that? Who got that?
Yeah, but
Anybody?
explain that to us, sir.
It's the first times the derivative of the second plus the second times the derivative of the first, right? So what we're doing, let me just look at the question and let me just rework the question here so you can see it fresh. Y is equal to 2x minus 4 e to the 7x plus 1. So it's a product. I have this as my first term and I have this as my second term. So dy by dx is going to be equal to the first, 2x minus 4, times the differentiation of the second. When I differentiate the exponential function, I get back the exponential function itself. So I'm going to write back e to the 7x plus 1. And then I'm going to multiply by the differential of the power. And when I differentiate the power, I get 7. Do you agree with that?
Yes, sir.
Good. So the first times the differentiation of the second plus the second says plus e to the 7x plus 1 times now the differential of the first. What's the differential of the first?
2.
2. So it's times 2. So I'm going to have dy by dx. So it'll be equal to 7 times 2x minus 4 e to the 7x plus 1 plus 2 times e to the 7x plus 1. E to the 7x plus 1 is common. E to the 7x plus 1 is common. So what I'm going to do is I'm going to factor out e to the 7x plus 1. So dy by dx is me factoring out e to the 7x plus 1. And what is going to be left is going to be 7 times 2x minus 4 plus 2. dy by dx is equal to e to the 7x plus 1 into 7 times 2x is 14x. 7 times 4 is 28 minus 28 plus 2 dy by dx is equal to e to the 7x plus 1 times 14x minus 26. And that's my answer. Obviously.
Understood, sir.
Mm-hmm. Simon?
Sir, I think I see how he got it.
Mm-hmm. Mario?
Yes, sir. Get in there.
Adrian, who is there? So this is a past paper question, 2018. So what I'm just doing now is just giving you some examples in another 15 minutes worth of questions on exponential and logarithmic functions, so you can just get your practice with them. Here was a 2018 past paper question. Don't know how many marks this one came for, but try that one for me, please.
So you could have show the rules for this one here again.
Yeah, I could, but just remember, the differential of the logarithmic function is going to be 1 over x. So the differentiation of ln x is 1 over x. You got that, Shamari?
Yes, sir.
Good man. So the differential of the logarithmic function is just mean 1 over x times the differentiation of the function. Steve. That's what I have. Anybody agrees with me? Anybody's close? Look at it.
No, sir, I got something totally different.
Can you look through what it is that I've done then and see if you understand what it is that I have? And then I can come and explain it to you.
I see how you got to your answer, sir.
All right. Mario? Mario?
Yes,
Are you
sir.
seeing it? Are you seeing it now?
Yes, sir. Sorry.
All right. So it's a product rule. So it's the first times the differentiation of the second. When I differentiate the second, when I differentiate ln x, I get 1 over x. So it's going to be 1 over 2x plus 1. But I have to multiply that by the differential of the function, which is 2x plus 1. And I'm going to multiply that by 2. And then I say plus the second, which is ln 2x plus 1, times the differentiation of the first. When I differentiate x squared, I'm going to get 2x. So what I have in blue is the end of my differentiation. What I have in blue is the end of my differentiation. All right. Now, let us try and simplify that. In simplifying, what I'm going to do is multiply the 2 by the x squared to give me 2x squared. And that is going to be times the 1 over 2x plus 1 plus this 2x I'm bringing it in front. So it's going to become 2x ln 2x plus 1. And then I recognize that the 2x is common. So I factor all the 2x. So I'm going to be left with x times 1 over x plus 1 plus ln 2x plus 1. And this x is going to be distributing over this one. So we're going to have x over 2x plus 1 plus ln 2x plus 1. Really not difficult. It looks that way, but if you apply the laws, the rules that I gave you, the first times the derivative of the second plus the second times the derivative of the first. The first times the differentiation of the second plus the second times the differentiation of the first. If you follow the rules, you should be good to go. I promise you. If you follow the rules, you should be good to go. All right. I did the exponential. Did I do an exponential function already? Yeah, I just did an exponential function and I did a logarithmic function. So I'm going to press pause. There are other questions on the exam paper. I'm going to press pause on those. And I'm also going to press pause on the square root function so that I can move into the implicit. Those are all past paper questions. Maybe not past paper questions, but questions that I would have generated for you. All right, let us use the last half an hour there, but just to, yeah, those are past paper questions, including the square root. And I'll do the square root with you. Don't have to worry about that one. I need to do the implicit differentiation. I'm going to ask you to, to read through for me. And when you're done reading through, let me know, please. So read through for, right, so there are 4. Let me just reduce it somewhat. So you have all 4 of them. All right, let's read through that for me, please. Some notes that I did for you. Read through those. When you finish read through it, let me know, please. Don't just sit down there. Remember to let me know when you finish. Don't just sit down there.
Finish reading now, sir.
Or if you if you can get what it is saying.
Not entirely.
Sorry, who was that talking? I don't know that voice. Who was talking just now?
Shamari.
No, not you. Someone just came in after that. Oh, somebody was talking in your background, Shamari?
Yes, sir.
Oh, okay. Because I heard a female and I was like, all right, cool. All right, so it says a function can either be explicit or implicit. It can either be explicit or implicit. An explicit function is of the form y, which is equal to some function of x. That's an explicit function. An explicit function is a function in the form y equals something, some function of x. That is, when we know x, we can calculate y directly. An implicit function, on the other hand, is of the form some function of y and x equals something else. That is, knowing x does not lead directly to y. It mix up. So our implicit differentiation mix up. It have x and y mix up, and you have to go hold one constant and differentiate the other one. So the steps involve: one, differentiate the function with respect to x. Therefore, when you buck up in a y, you have to include the dy by dx. Real talk. Then you can call it all the dy by dx on one side. You can solve for dy by dx. Optional, if given xy, substitute the coordinates into the differentiated function to evaluate what dy by dx is. I am going to predict one question here. I want your undivided attention. Let me know, all of you, if I have your undivided attention.
Yes, sir.
Thank you.
Yes, sir.
Cool.
Yes, sir.
All right. Okay, so I don't have Adrian's attention. Let's go. I'm not even going to project the answer. I'm going to work the question. So it says, if x squared plus 3xy plus y squared equals 16, find dy by dx. Sir, whenever you say you were dy by dx, it was always explicit. Y is equal to some function of x. And then we'll find dy by dx and we'll work it. How are this now, sir? X and y mix up together and I want something? Not a problem. Let's go. So we are differentiating as per usual. So when I differentiate, and I want you to speak to me now. When I differentiate x squared, what do I get?
Two X.
I get 2x. And watch me now. I am going to differentiate 3xy. I'm differentiating 3xy. It's a product. So I'm going to say the first, which is 3x, times the differential of the second. When I differentiate y, I'm going to get 1, but I have to put dy by dx. So that's the first times the differential of the second plus the second plus y times the differentiation of the first, which I'm going to get 3. Let's go again. It's a product. The product rule. So differentiating 3xy, the first is going to be my 3x times the differentiation of the second times 1. When I differentiate y, I'm going to get 1. But because it's a y, I'm going to put dy by dx. Plus the second, which is y, times the differentiation of the first. When I differentiate 3x, I'm going to get 3. Plus, when I differentiate y squared, I'm going to get 2y. But because it's a y, I must have dy by dx. And when I differentiate 16, the constant, what do I get?
0.
0. So watch me now. I'm going to have 2x. All of that is going to give me plus 3x dy by dx plus 3y plus 2y dy by dx equals 0. I'm collating all the dy by dx's on one side. So I'm going to say 3x dy by dx plus 2y dy by dx is going to be equal to negative 2x minus 3y. Talk truth. Look at that and tell me if you agree.
I agree, sir.
Same here, sir.
Rest of you, Simon.
Yes, sir.
All right. So I'm going to factor out my dy by dx. So I'm going to say dy by dx times 3x plus 2y. I'm factoring out the dy by dx is equal to negative 2x minus 3y. And then now what dy by dx will be the subject of the formula. So I'm going to divide both sides by 3x plus 2y. And then all of this cancels with all of that. So I have dy by dx to be equals to negative 2x minus 3y over 3x plus 2y. And I can factor out a little bit more. I may have factored out the negative signs out in come on. In my answer. Yes, see, so I told you, right. So I would have factored out the negative sign in my answer, right? But what it is that I would have done, let me just minimize. What I would have done in the question that I just explained, I would have done the question before, and I just did the question with you again because I want you to see it. I'm going to give you 3 minutes to look through that for me, to tell me if you understand what is happening, and then I'm definitely going to be sending some more of these questions. I'm going to send this example to you and some more of the questions, some questions for you to do on this topic for me. But look at that. Take 3 minutes and look at that for me. 3 minutes. We're wrapping up. 3 minutes. How we feel? How we stay? Hmm? For crying out loud. Somebody answer, please.
Did I look on it, sir?
Okay.
Just have a question, like I was wondering how come you knew that the first term was 3x and the second term was y. For the 3xy,
Mhm. Well, you answer that question. 3xy. I can't differentiate two terms, two different variables at a time. I have to differentiate it one at a time. So I recognize that the 3x is being multiplied by y. True or false?
true.
So since 3x is being multiplied by y, 3x is one term being multiplied by y a second term. So I just use one of them as one term.
I'm like your explanation, sir.
Mhm. Simon, are you still with us?
Yes, sir, I'm still looking.
Are you okay?
Yes, sir, I'm making notes and everything.
Okay, good. Adrian, I have called upon you several times and you have not answered one time.
Sorry about that, sir. I come on class late, but I just have follow through.
Yeah, but when I ask you the question, it is nice for you to answer me. But when you
No,
ask
sir,
me a
you know,
question,
I never hear you. I never hear. God no. I never hear you.
no, I'm
Never
gonna take
hear.
I'm gonna take it personally now.
No, sir. I never hear, man. God no.
All
No,
right.
me not do it.
Finish, Amari? Are you still going through?
Yes, sir, I'm finished now.
All right, cool. Simon, finish or still going through?
Yes, sir, I'm finished. All right, on everything.
Um, I know it's I know it's I know it's a lot we took in tonight, but if you understand the position that I'm in, I if you understand the position that I'm in, I have to go through as quickly as I can, but try to slow it down so that at least I know that you're still understanding. I don't want to keep you beyond 9 o'clock. At this point in time, I'll take your questions. If there anything that you want me to, let me go through this solution. If there anything you want me to go through, I can go through it in another couple of minutes. Just remember, whenever you differentiate a y, you have to write dy by dx. Why, sir? Because we're not doing an explicit differentiation. We are doing an implicit differentiation. So therefore, for the implicit differentiation, where it is that we have the multivariable in the question, we have to do, whenever we differentiate a y, normally, we then write dy by dx. When we differentiate x, it stands alone. But whenever we differentiate a y, For example, if we have y squared, we're going to differentiate the y squared as normal, 2y. So y squared, I differentiate it, I'm going to get 2y. But I must write my dy by dx. If I get 3y, I'm going to differentiate the 3y as 3. But I must have my dy by dx. I will send some. But go ahead, Shamari.
That me don't ask you about the questions.
Yeah, I'm gonna send some questions tonight. I'm gonna generate some questions now, and then I'm gonna send you the questions. My question to you though is, do you want me to do the solution and send you the answers, or just send you the questions? If I send you the answer, I won't send you the workout, you know. I'll just send you the answer alone. So at least you can look to see if what of your workout results into the answer, or I could just send you the question. What say you?
Sir, I would prefer it with the answer because yeah, last time we didn't, like, when we asked for like to send a question, we didn't receive the answer. But I know it wasn't on you, but I would just want the answer so we can verify it's correct.
Okay, all right. So look out for it in another couple. I went deep before I even decide to go cool off after these 3 hours, because if I know I cool off, I'll get cool off and drop asleep. So I'm going to do it now and send off to you. All right. Thanks for coming out. Have a good one.
You as well, sir.
So cool.